Let's go over the homework. I might do this in 2 videos so that it doesn't cut off in YouTube. So let's try 79 and 78 in one video, and then I'll do the other ones in another video. So let's get going. We have lesson 79, an average number of problems today. You can see right there. Okay, so let's start with lesson 79. Let's start with the first one, I guess practice problems. Nobody had trouble with those. So let me turn to that page in the book. 79, the practice problems were converting. So apparently you guys did okay with those. Good job. Okay, number 3 is what's the percent weight of carbon in carbon dioxide? So this is number 3. Carbon, we only have 1 carbon. We have 2 oxygen. The carbon weigh 12. The oxygen weighs 16. So the total carbon would be 12. The total oxygen is 32. We add those up and we're going to get the total weight, which is 44. Now we want to figure out the percent of carbon. So to figure out percent, all you do is take 12, the carbon divided by the total, and you're going to get 0.27, and it just keeps repeating, so you can just put a line over that. So that's going to be 27. They want percent, so you move the decimal over 2 places, 27.27%. So you're taking it to 2 decimals, so you're just going to round, which would be 7. Number 3 is done. Let's move on. Next one looks like number 5. Number 5 says, when the hoplites collected their weapons, they found the ratio of swords to spears was 2 to 7. Further, they found that 5 times the number of swords exceeded the number of spears by 120. How many of each did they have? I use W for sword and P for spears. I know it's weird, but they both start with S. So the ratio of swords to spears. So this is number 5. The ratio of swords to spears was 2 to 7. Then it said 5 times the number of swords equals the number of spears plus 120. So exceeded it by 120. Now we're just going to do a plug-in. We need to solve for one of the variables and substitute. I'm going to solve for this P because it seems easiest to solve for. So 5W minus 120 equals P. Then I'm going to take this, because that's what P is equal to, and put it into the other equation. So W over 5W minus 120 equals P. Doesn't equal P, equals 2/7. Oops, oh my goodness, I just erased the whole thing. So we have W over 5W minus 120 equals 2 over 7. And then we'll cross multiply. So we get 7W equals 10W minus 240. And we just solve for W, so we get negative 3W equals negative 240, and W equals 80. And then we can figure out what the spears are by plugging it back into the equation that I erased, which is that one. And so we're going to get the number of spears that starts with a P, which is 280. All right, 1 sec. My dog is in the trash. Hold on. Oh, I thought Kim was in the trash. All right, it wasn't my dog in the trash. My son was just eating chips. Huh. Okay, let's go on to number 9. So this one is a radical one. Now, please note, when you're doing radicals, you have to check your answers. I just did an SAT problem. I was just doing a SAT practice test for fun, and one of the numbers didn't work. And if you wouldn't have plugged it back in, you wouldn't have known that. Now, these all work this week, but sometimes they don't. Okay, when you're doing these radical problems, first of all, S is a really terrible variable. But when you're doing that, you want to isolate the bigger radical. Since this one's negative, I think I'm going to put that on that side and get the square root of S minus 8. And then I'm going to bring the square root of S on the other side. Now, to get rid of your radical, you square both sides. So we're going to square both sides. We're getting rid of the big radical first. So I can barely read my writing there, but it's S minus 8. Equals, now we have to FOIL this. You can't do 16 minus 5. This is the same thing as this times this itself. But the mature way, which I always do, and I'm so happy that I know how to do it the mature way in foiling a binomial, is you square the first term. You multiply the two terms together, so it's going to be negative 4 square root of s times 2. So it's going to be negative 8 square root of s. And then you square the last term. Square root of the square root of s is just s. So now we're just going to isolate that radical. So the s's cross out, fortunately. Get rid of some of those s's. We're going to subtract 16 from both sides. So let's see, what did I do? Something's a little bit different than what I did before. They should both be the same sign. Hold on 1 second. We should get negative 24. Let's see, last time I did it on the other side. Oh, did one of my numbers change? Nope. So hold on a second. It's partly because I can't read my work. 4 minus the square root of s. This is going to be plus s. This is 4. Anybody see what I did wrong here? So if I subtract 16, I should get 8 and not whatever I got. Let me just do this one over the way I did it before. Sorry, making the video longer than I need it to be. Square root of s equals 4 minus the square root of s plus 8. All right, I'm going to subtract the 4 from both sides. And then I'm going to get negative square root of s plus 8. Now we're going to square both sides, and I don't know why it didn't work last time. Okay, the mature way is you square the first term. We're going to get s, multiply these together, you get negative 4 square root of s, so it's going to be negative 8 square root of s, plus 16. Square this side, we get s plus 8. Okay, it's the same thing. So the s's cross out. We get negative 8 square root of s plus 16. I guess I had it right before. Equals 8. No, maybe not. All right, so now we're going to get, let's subtract, we have to isolate the other radical, equals negative 8. Divide both sides by negative 8, so we get square root of s equals 1. And so we're going to get s equals 1. You have to check these, so go back in, put the 1 in, and it does work. So make sure you check radicals. Drill that into your head. Okay, number 11. 11 is, okay, this one might have been a little bit torturesome for you. So let's see if we can do this together. I don't know where I did this problem on my paper, so here we go. We have this. If I draw the picture, and whoa, that looks a little scary. Let me do that again. I'm always trying to rush these a little bit too much because there's so many problems and I don't want these videos to last forever. Okay, so you have a force coming down this way acting on a point. So that's our first force right there. And then we have another force acting on the point. This one is at 40 degrees. It's too long. And then we have another point, another vector acting on the point. This one's a little bit bigger angle. Mine won't look any bigger. You can look in the book if you need a better drawing. 45 degrees, and this is 1. So we're going to do our whole thing, putting them into rectangular coordinates. I'm trying to find where I did this problem so I don't have to use a calculator to do this. Okay, I think I got it. Okay, so we're going to let's do the 40 degree one first. So we get x equals 2 cosine of 40 degrees. And remember this, y equals 2 sine of 40 degrees. We kind of memorize how to do this. All right, now, it's going in the positive x direction. It's going from here to here, so our x is going to be positive. That's a little confusing, but that's just how it is. So we're going to get 1.53. Now, check it out. The y is going down, so it's going in a negative direction, so we're going to get negative 1.29. That's our y. Okay, let's do the second one. So we get x equals 1 cosine of 45. It's going in the positive x direction, so it's going to be positive. So it's going to be 0.7. And it's going in the positive y direction. It's going up. So we're going to get y equals 1 sine of 45, and the sine and cosine of 45 both the same. It's 0.7, 0.71. Let's put the 1s there. Where did I put the 1? Okay, now you're going to add your x coordinates together. So let's add our x's. We're going to add this one and this one together. They're both positive. So our x, I'm going to just call it x final. I should have called them x1 and x2, is 2.24 up. And when we add our y coordinates together, we're going to get a negative value. So y equals negative 0.58 right. They want this back in polar coordinates. So this means it's going to be a really long problem. So I'm going to plot this point like such, and we're going to go to the x distance 2 down 0.58. So I just want to know what quadrant we're in. That's why I draw these triangles. So our x would be 2.24. Our y is negative 0.58. You have to do the Pythagorean theorem. So you need to put in your calculator, this squared plus this squared equals this squared, and then you have to take the square root, and we get, ooh, I don't know where I wrote the answer at for this. So we get something, 2.31, I do believe, 2.31. So then we need to figure out this theta right here. So we use the inverse tangent to find the theta. So it's going to be opposite, which is negative 0.58. Put the negative in over the adjacent, which is 2.24. And when you do that, out will pop a number. I think it's 40. We're going to get theta equals 41.8, but negative 41.8. So it's coming down this way. But we have to find this angle going the whole way around. So you need to take 360 minus 41.8, and you're going to get 345.48. So a little tricky, a lot of things going on in this problem. And finally, we write it in polar form. So our vector length is 2.31 at, now make sure you go the whole way around. So it's going to be 345.48 degrees. And that is your final answer. That was a tough one. Lots of things going on that could trip you up on that. Okay, if you need to rewatch that one, go and rewatch it. So we are now on we're still in the first lesson. Blah. Okay, number 11. What is 11? Oh, we just did 11, yay. Okay, so we are on 15. 15, guys, it's on page, I think, Shannon, you asked this both times, how to derive the quadratic formula. It's on, for number 15, go to page 297 in your book, or see the video I did last week. I did the same problem last week. You just have to memorize it if you're not getting it. Okay, in the last, nope, we have problem 21 and 23. So 21 is use the quadratic formula. I'm going to give you a quiz on using the quadratic formula this week. So make sure you come in with it memorized. I'll give back the other quizzes that you took. Hopefully you heard this on this. I might put it on our Google Classroom. So you need to know the quadratic formula. So x equals negative b, so it's going to be negative 2. Plus or minus b squared, so it's going to be 4. Minus, for b squared minus 4 times a times c all over 2 times a. You need to know that by like the back of your hand. It's a really important formula. So you get x equals 2 plus or minus, when you simplify underneath there, you get 16 over 6. The square root of 16 is 4, so it's going to be a little bit different. No radicals in the answer, over 6. So you're going to do 2 plus 4 divided by 6, which would be 1, right? 2 plus 4 is 6. So you're going to get x equals 1. And then you're going to get 2 minus 4, which would be negative 2 over 6, which would be negative 1/3. So those are your two answers. Quadratic equations give you 2 answers. Okay, the last one is number 23. Alrighty, so 23 is a triangle. You're supposed to use similar triangles to find A and B. Actually, I forgot Chad's number 20. Did you just sneak that in there, Chad? Missed that one. All right. So 23 is use similar triangles. So you just want a right triangle here. There's different ways to do this. I probably would just try to figure it out using different methods. But they want you to use it using similar triangles. So this is a right triangle. This is 45 degrees. So you know this one has to be 45 degrees. This side is the square root of 3. So you know these sides are going to be the same because they're opposite congruent angles. This is the square root of 3. You could use the Pythagorean theorem. Or you can use like what they said. You make a similar triangle where this sides are going to be 1, 1, square root of 2. And then you do a ratio. So you do the square root of 3 over x equals 1 over the square root of 2. You cross multiply and you get x equals the square root of 6. Or you could have done the Pythagorean theorem because it's a right triangle. Okay, Chad, I did one of these coming up, so I'm going to save your problem. So if you have trouble with that one, just wait until I get to the one that I already did. All right, let's go on to lesson 81, and then we'll take a little break. So lesson 81. Oops, I skipped lesson 80. No wonder. Okay, never mind, Chad. Never mind. I was doing the wrong lesson. But that was the right problem. Okay, lesson 80, number, looks like 4 is the first one. Number 4, it is, let me just turn the page. Okay, the place was crowded because 3 1/4 times as many people would come to the fire marshal as the fire marshal would permit. If 650 had come, how many would the fire marshal permit? So, this is the whole thing where you have the fraction times the total equals the part. So we're trying to find the total. The fraction is 3 1/4, so that's going to be 13/4. We don't know the total, so it's going to be t. The part is 650. Let's multiply both sides by 4, so we get 13t equals, I did it all in one step last time. So let me do it one step this time. Multiply both sides by the reciprocal. So it's going to be 4 over 13. So, and this is going to be 4 over 13. And so we're going to get our total equals, I kind of just took 13 into 650 and then took it times 4. And so the total is 200. All right, number 6. 6 is another big fat radical, and I did it because it's a newer problem. I'll do extras of these. Minus x plus 2 equals 0. Isolate your bigger radical. This one's a little bit different because it doesn't have 2 radicals. So we're going to isolate this radical, x squared minus x minus 2. If you have a radical in it, make sure that you check your answers. Mostly for the SAT. Okay, let me see. Did I copy this one right? Yes. Now we're going to square both sides. Square and square. And we're going to get x squared minus x minus 2. And then we're going to use the mature way. Please learn this. It's not x squared plus 4, first of all. It's x minus 2 times x minus 2. The mature way is you square the first number. You multiply these together, so you get negative 2x times 2 gives you the middle number. So it's going to be negative 4x, and then square the last one. I use that every time. It's so speedy. These cross out. Let's bring the x's to the left, so it's going to be 3x. Bring the numbers to the right equals 6. X equals 2. When you check this, I do believe it does work out. But you go in here, you would do 4 minus 2 is 2. Minus 2 is... Yeah, does it work out? 2, it'll be 4 minus 2 would be 2, minus 2, 4 minus 2 is 2, minus 2 is 0, minus, so it's going to be 0, so it's going to be negative 2 plus 2 equals 0, 2 equals 2. Yep, it checks. Okay, let's go on to number 8. I think it's the same idea, guys. All right, I already did enough of these. So let's move on. I'm going to skip that one even though I did it. Let's do, the next one is 20. Here's your 20, Chad. I was in the wrong lesson. All right, this is an I problem. Yay. Okay, with these, the biggest thing is you have to be super duper careful. Everybody can do these, but it's the problem that people make the most mistakes on because it's kind of tedious. Square root of -2, square root of, I'm actually running out of room, minus 4i to the 4th. All right, so we're just going to start from left to right. The square root of -4 is going to be 2i, so it's going to be -2i. The square root of -9 is 3i. I to the third is the same as I squared times I. I squared is -1, a negative times a negative would be a positive I. Now, for this one, you pop your i's out first. So you have the square root of 2, square root of 2, and then we have an I squared, one from each of these. You can't multiply them together and make them a positive 4. It doesn't work. The i's have to pop out. So square root of 2 times the square root of 2 is 2. Let me just back up a second. This I squared is a -1, so it's going to make this a negative sign. 2, and then this is going to be I squared times I squared. It would be -1 times -1, which is a positive 1, so this does not change. Put your real numbers first. So we have a -6. That's our reals. And then what do we have here? We have a 1i and another I, and we're going to get a 2i. And that is that. Just, it's really easy to make little dumb mistakes on that. Okay, number 22. Use the quadratic formula to solve. All right, a little bit different, so I'll do this one. 22, know the quadratic formula. Really key. So you have -x squared equals -x minus 5. Set it equal to 0 because it's quadratic. I'm going to move everything to the right because I like positive numbers for my x squared term. All right, now a is 1, b, whoops, that's not a 1. B is -1, and c is -5. You just plug that in where the a, b, and c's are in the quadratic formula. So x equals b squared, which would be 1, plus or minus 1 minus 4 times a times c, whoops, all over 2 times a, which would just be 2. So you're going to get x equals 1 plus or minus the square root of 21 over 2, and nothing can be simplified or reduced. It's an unusual problem, so that is the answer. And 24. Okay, this one, I can see why you guys missed this one. It was like a trick question. Hey, but this is the kind you're going to see on the SAT, and that's what we're prepping for. Oh, that was good. Okay. So we have, it's basically 2 circles with radiuses of 6. Okay, so I'm going to find the area. So you're supposed to find the volume. To find the volume, you find the area of the bottom times the height. So the area of the base equals pi r squared. And so it's 2 circles, 2 half circles, which makes a whole circle. So it's going to be 36 pi. And then when we multiply that out, it's going to be 113.1 inches squared. Now, read the problem carefully. The problem says how many 1-inch cubes. This is in inches, but it tells us that the height is 6 feet. So before I multiply it by 6, I'm going to take it times 12 to put it into inches, so it's going to be 72 inches. So we're going to take this number times 72 inches, and our final answer is going to be 8,138.88 inches cubed. So if you got the wrong answer, my bet is you took it times 6 instead of times 72. You have to convert your feet into inches. And the last problem, oh my, we do this all the time. We got to get this. I don't know what to do to get this to sink in. Maybe I'm going to give you a quiz on this too. Okay, find an equation of a line that passes through the point -2, -3, and is perpendicular to -x minus y minus 1 equals 0. So first you need to find the slope of the line that they give you by solving it for y. So we're going to get -y equals x plus 1, y equals -x minus 1. So the slope of this line is -1, number before the x. So the perpendicular one is a negative reciprocal, but it's just a 1, so it's going to be just +1. So you find the slope, then you find the perpendicular slope, and then you take y equals mx plus b, and you put the -3 in for the y, the 1 in for the m, the -2 in for the x, and you find b. And so we're going to get b equals -1. Right, that's -2, so b equals -1, and then you do y equals the new m, the perpendicular m, which is 1x minus 1. Boy, it looks really similar, doesn't it? All right, so that does it for lesson 80, and I'm going to come back and do lessons 81 and 82 so that it doesn't get cut off on YouTube, I hope.